Hi everyone, we're going to find the derivative of the function using the definition of derivative. We're also going to state the domain of the function and the domain of its derivative. So let's just first look at the domain of this function here. That just means our denominator cannot equal 0. So if we set this to not equal 0, we have 2x cannot equal 3 when you add 3 to both sides, so x cannot equal 3 halves. So it can be everything but that. So you would write it as negative infinity to 3 halves, or 3 halves to infinity. It's like that. And then when we'll get to the domain of our derivative, we'll compare the two. So there's that. And let's find the derivative using this definition of the derivative. It's the difference quotient, but you're taking the limit, and that's going to be your derivative. So we're going to have f prime of x equals the limit as h approaches 0. Now we're going to take this x and substitute in x plus h. So this is going to be x plus h squared minus 1 divided by 2 times x plus h minus 3. And don't forget to include those. And then you subtract the whole function. So we're subtracting x squared minus 1 divided by 2x minus 3. And then we're dividing this whole thing by h. All right. The next step, let's just look at the numerator and get our common denominator. So basically, the common denominator is going to be, let's look at this real quick. This right here is just going to be 2x plus 2h minus 3. All right. And then this is going to be 2x minus 3. So we're going to have the limit, excuse me, as h approaches 0, and your denominator is going to be 2x plus 2h minus 3 times 2x minus 3. Now, what we can do is go ahead and, since we're getting the common denominator, just cross these two. So what you're going to get is this one is going to be x plus h squared minus 1 times 2x minus 3 minus, then we have x squared minus 1 times, and I'm just going to write this one, 2x plus 2h minus 3. This h here I can move up here. So I can move this h up here. I'll put it here. Now from here on out, what I'm going to do to make this easier, because we're going to have a lot of work to do in this numerator, I'm going to call this part d for denominator. So this is going to be d, and now we're going to simplify our numerator, and we'll leave the h out because we're going to have to get rid of that. So I hope that's, if not, if I have to keep doing the denominator, it's going to get really messy, and it's going to take too long. All right, so let's clean up our numerator. I'm going to expand this. So we're going to have the limit as h approaches 0. We're going to have x squared plus 2xh plus h squared minus 1 times 2x minus 3 minus 2x plus 2h minus 3 times x squared minus 1. And this is all over h times that denominator. So I don't have to keep copying that down. So this denominator will input that later. All right, so we're going to fix all of this. This is going to be the limit as h approaches 0. And this is going to equal 2x cubed plus 4x squared h plus 2x h squared minus 2x minus 3x squared minus 6x h minus 3h squared plus 3. All right. Now we have to do this one. So this is going to be minus, and I'm going to write this here, 2x cubed plus 2xh. Oh, it's 2x squared h. Minus 3x squared. I have to move this down. I'm going to move this down a little bit. Minus 2x cubed plus 2x squared h minus 3x squared minus 2x minus 2h plus 3. Okay, and this is all divided by our h times that denominator. Now, let's cancel things out. Let's see, these two will cancel out. These two will cancel out because remember it's minus, so minus a negative. All right, that's going to make it a positive. These two will cancel out. Anything else? The 3's will cancel out. And now let's see what we have. Let's finish up. We're going to just have left things with h in them. So here are our h's, and we can group those together. So let's do that. We're going to have the limit as h approaches 0. This is going to give you 4x squared h plus 2xh squared minus 6xh minus 3h squared minus 2x squared h plus 2h. Okay, all divided by this h times that denominator we had. So the next step is just to factor out an h, because we have h here. So we can write this as the limit as h approaches 0 of h times 2. We're adding, let's see, 2x squared plus 2xh minus 6x minus 3h plus 2. All right, so basically I combined these two and anything else. I did a bunch of combining. And then we have h times your denominator. Now what happens is the h's cancel. All right, so now let's take the limit as h approaches 0, and we're going to have 2x squared plus 2xh minus 6x plus 3h plus 2. And now I'm going to write my denominator. My denominator without the h now is 2x plus 2h minus 3 times 2x minus 3. Now applying the limit, all the h's are going to go away. So this h will go away because that will zero out, and this will zero out. And then this one will zero out. And it looks like we have 2 of these, because this is going to be 2x minus 3, and then we have 2 of them, so that's going to be squared. So our final answer is going to equal, so I'll just put f prime of x equals 2x squared minus 6x plus 2 divided by 2x minus 3 and squared. Now, as you recall, our domain of f was negative infinity to 3 divided by 2, united with 3/2 to infinity. And if you look at our denominator here, it's the same thing. So this also equals our domain of our derivative. All right, and that's it. Thank you. Have a nice day. Bye-bye.